Welcome to viewers and students. Today we will discuss a very useful property of a right angle triangle. We have earlier discussed some basic properties of triangle. Say for example, angle sum property. The sum of the three angles of a triangle is 180 degree. Then we discussed sum of any two sides of a triangle is greater than the third side. Then exterior angle of a triangle is equal to sum of the interior opposites, and sum of the exterior angles of a triangle is 360 degree. Now here we will discuss a very useful property of right angle triangle. This is known as Pythagoras Theorem. This was developed by a famous Greek mathematician Pythagoras. He says that in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of other two sides. Now let us consider this triangle ABC. It is a right angle triangle. Right angle at B, angle B is 90 degree. Now here the side opposite to right angle is known as hypotenuse, and other two sides, they are perpendicular to each other. We call the side BC as base. It is lower side of the triangle, and this side AB we call it perpendicular, right? Now the Pythagoras theorem says that square of the hypotenuse means AC square equal to sum of the square of other two sides, means AB square plus BC square. So we will try to prove this theorem here by cutting paper cutting method. Now let us consider these 8 right angle triangles. To prove this property, we are considering 8 right angle triangles here. You see, all these triangles are identical. These are 8 right angle triangles. Now let us this side say, suppose this is B, this side is B suppose, and hypotenuse is suppose A, and other side is suppose C, right? So in all these right angle triangles, we are considering the hypotenuse, measurement of hypotenuse is A, perpendicular side is suppose B, and other side is suppose base is suppose C. Now we are taking two squares exactly identical. These two are equal squares, right? So we are taking these squares with measurement say B plus C. Suppose here B is, length of this side B is, here it is 3 centimeter, and this is 4.5 centimeter. So in this square, we are considering the side length of this square is 7.5 centimeter. That means B plus C. The side length of this square is B plus C. All these are B plus C, right? All these sides are B plus C. Right? These two squares are exactly identical. Now let us fix this triangle here. We will try to fix 4 triangles in this square sheet. Say this is fixed here. Right? Then this triangle is fixed here. Then this triangle we will be fixing here. And one more triangle we will be fixing here. Right? So you see this length is B, this is C, so side of this square is B plus C, right? This length is C, this is B, so side length of this square is B plus C. Now another triangles. Rest of the 4 triangles we will be fixing here. Let us fix it here. Okay. Now you see, in both these squares, originally these two squares were identical. You see, these two squares are identical. Both has same surface area of the two squares were same originally. Now you see, these two squares were some spaces, some surface areas of these squares were occupied by triangles, 4 triangles here, and in another square we are using 4 triangles. Now you see, the left out space, it is again a square, right? This is a right angle triangle. All these angles are right angle, so it is a square again. So what is the area of this square? The area of this square is, since it is a, so area of this square is a square. So the surface which is not yet occupied by triangles, it's a square, so area of the square is a square. Again you see, in this square, the area of this square is it was originally c, so it is c square, and this side was b, so this is again a square, so area of the square is b square. Now you see, in these bigger squares, in both cases, right, only 4 triangles are used, so amount of space left out here and here are same. The amount of space left out in this square, bigger square, and in this bigger square, they are same, because we are using 4 triangles in each cases. In this bigger square, we are using 4 identical triangles, right? These are identical triangles, 4 triangles here we are using. In the next square also, we are using 4 identical right angle triangles. Now this side was originally c, length was c, so area of this square is c square, and this side was originally, it was b, so area of this square is b square, and this side was originally a, so area of this square is a square. Now you see, the left out area which is not yet covered by triangles in both cases are same. That means a square equal to b square plus c square. So what is a square here? A means here the length of the hypotenuse, right? B means the perpendicular length, and c means the base. So area of square of the hypotenuse equal to sum of the square of other 2 sides. This is how you can prove the Pythagoras theorem by paper cutting method. So first we used 8 identical right triangles, right? So the side length of this right angle was, this was c, this perpendicular was b, and this hypotenuse was c. And then we considered 2 identical squares here. These 2 are identical squares, they are same. Then we used 4 right triangles here in this square, and another 4 triangles in this space. Now you see, the left out space in both cases will be equal, because we are using same number of triangles in both cases. So area of this green surface and sum of the area of these 2 green surfaces must be equal, because we are using 4 numbers of right triangles in both pages. That means area of this green space is a square, equal to sum area of these green spaces means b square plus c square. Now what is a square? A square means square of the hypotenuse, and b square means square of the perpendicular, and c square means square of the base. So in a right triangle, sum of the square of perpendicular sides equal to square of the hypotenuse. Thank you, viewers. We will discuss some mathematical problems on Pythagoras theorem in the next class. Bye bye.